Hello everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video we're going to be looking at an equation, an exponential equation with complex numbers. We have 1 plus 3i all to the power n equals 3 minus I, the quantity 3 minus I to the power n. And we're going to be solving for n values. That's why n is red, right? Obviously, I is a constant, so what else can you solve for? There's no z in the equation, but we are dealing with complex numbers. And I'll be presenting at least two methods, and let's see how this goes. And start with the first one. So first of all, I want you to notice one thing before I get into the solution methods, that if you just say that, okay, when the exponents are equal, the bases are also equal, you're gonna run into a problem. Why? Because if this implies 1 plus 3i equals 3 minus I, which is definitely false, because negative 2 does not equal negative 4i, as we know, right? Obviously. I is an imaginary number. It's the square root of negative 1. I squared is negative 1, but this is not true, right? So we can't just simply say that, okay, the bases are equal. So what are we supposed to do then? We need to approach it more systematically. So let's go ahead and take a look at the first method. So for my first method, I kind of want to get into the polar coordinate system, okay? So to be able to do that, I want to consider the following. I know my coordinate system is not very straightforward, but hopefully you'll bear with me on that one. So 1 plus 3i is basically you pick 1 unit here on the real and 3 units on the imaginary, because this is 3i, as you know, this is 1. And then we're going to get a point which can be called 1 plus 3i. Or 1 comma 3, same thing, right? And this basically gives us two things. A point and then a distance from 0. So if you go ahead and connect it to 0, like this, and that'll make an angle. Let's call that angle theta. And by writing this number as re to the I theta, you're basically using the polar form of a complex number, thanks to Euler, right? E is Euler's number, R is the modulus. The modulus can be found using the Pythagorean theorem. As you know, the modulus is the square root of 1 squared plus 3 squared, and that would be the square root of 10. Awesome. And just use the theta, so we can basically write the left-hand side as square root of 10 times e to the power I theta. And theta is the theta that I'm just displaying on the coordinate system. This is my left-hand side. Let's go ahead and raise it to the power n. And on the right-hand side, we have 3 minus I. We kind of need to do the same thing for 3 minus I. 3 minus I is a little different, because if you go ahead and pick 3 units this way and 1 unit down, so you're going to end up here. And now your angle is definitely going to be a different one, right? But guess what? They are going to be related. So let's kind of make these look like vectors with an arrow. And here, the argument can probably be defined as, there's actually two ways to define it. One way is start at the positive real axis and then go counterclockwise. But we want the argument to be between negative pi and pi, so why don't we just use a negative approach, which is fine in this case. So I'm going to go ahead and use my angle this way. Remember, last time I used it this way, and that's perfectly fine. And would this be negative theta? No. If you think about it, actually, that is going to be negative theta, I believe, right? No, that's not the case, because if you think about these two right triangles, theta happens to be the larger acute angle, and in this case we're talking about, so this is theta. I'm not talking about any directions, just the value, and this should be 90 minus theta, right? But if I say 90 minus theta, would that represent a negative angle? That wouldn't, because the thing is 90 minus theta would be something like this, if you think about it. So I kind of need to take the opposite. Makes sense? That's kind of tricky, but if you really think about it and be familiar with the unit circle or the coordinate system, that shouldn't be too hard. So this is 90 minus theta. I need the opposite of that, which is theta minus 90. Make sense? So by the way, the r is the same for both of these, okay? So it's going to be the square root of 10 again, but this time we're going to have I times theta will be replaced with theta minus 90. And then, of course, I still need to raise it to the power n. Okay? So where do we go from here? Well, first of all, notice that we can square root of 10 to the power n is going to cancel out. Nice. But what about the angles? Let's find out. So let's go ahead and expand it. It's going to look like this. E to the I n theta, and then root 10 to the power n, e to the power I n theta minus 90. Awesome. These two terms are going to cancel out. Nice. And then what about the rest? Let's go ahead and set the exponents equal to each other. I n theta equals I n theta minus 90. Now, again, we're going to run into some problems. You know why? Because if you just cancel out the I n, you're going to get theta equals theta minus 90, but this equation has no solution whatsoever, right? Even in complex world, it doesn't. Because a number, 90 less than a number cannot be the same as the number, right? Obviously. So what do? We do some adjustments. So remember, we had this, right? One thing we can do is we can actually add a multiple of 2 pi ki. And the reason that works is because e to the power 2 pi ki is equal to 1. That's the complexified version of 1. So we're able to multiply the right-hand side only by that. And then we're going to get a nicer expression. Let's go ahead and find out. I n theta equals I n times theta minus 90 plus 2 pi ki. Now we can go ahead and simplify, like cancel out the I easily, not the n yet. Let's go ahead and find out. We're going to get n theta equals n theta minus 90 n, right? Plus, and again, remember, we're not trying to solve for theta because we could easily, right? With the arctangent, we're trying to solve for n, so that would be helpful. And then we can go ahead and kind of cancel these out as well. And then 90n equals 2 pi k. Oh, by the way, I think I made a mistake here because I used 90 degrees. I should use pi over 2 because we are using radians, right? So that should be changed into pi over 2, which can easily be done, by the way, not too hard. And this would be pi over 2. And then from here, hopefully we can solve for n, right? That's the goal. Again, pi cancels out, and then we can go ahead and cross multiply. N equals 4k. By the way, I forgot to say about n and k are integers, particularly k. I mean, you necessarily did not know what n is, but it turns out because k is an integer, then n must be an integer too. So, looks like we have a solution. Nice. And let's see if we can solve it a little differently, right? Obviously. So the first method was kind of a little brute forcey, right? But it works. That's the nice thing about it. The second method is going to use a really nice property. And that is, we're going to divide both sides by 3 minus I to the power n. And when you do that, because that's not 0, we can do it. We're going to get 1 on the right-hand side. And since they both have n, we can go ahead and put these together. Now, is this property valid even when n is not an integer, when n is complex? Think about it. Those are good questions. But anyways, let's go ahead and simplify what's inside, right? How do you simplify this? There's a couple of ways. I think the most straightforward method, the easiest one, is just multiply by conjugates. And when you distribute, you're going to see something weird. 3 plus I plus 9i plus 3i squared. But I squared is negative 1, and this is 10. You know that, right? So this is negative 3. That's positive 3. Awesome. This gives us 10i divided by 10, which is I. Beautiful. So that complicated looking expression is actually I. So that gives us I to the power n equals 1. And as you know, I to the 4th power is 1. Any multiple of 4 will do, because as you know, I to the 4 to the k is always 1, because I to the 4th is 1. Therefore, from here we get n equals 4k, where k is any integer. And that almost brings us to the end of this video, because we still have to look at something. The result from Wolfram Alpha. If I did not forget to include it, oopsies, I did forget. I guess it was too obvious. Maybe I just totally, I don't know. This brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.